Hello students, today we are going to start pair of linear equations in two variables, okay, that is of class 10. Before starting this pair of linear equations, let us start with a linear equation, okay. So what is this linear equation? Okay, first let us start with linear equation. An equation which is in the form of ax plus b is equals to 0 is called as a linear equation, right? And here, what is the variable here? It is in one variable, that is x. Variable is x. So this is called as a linear equation which is of the form ax plus b is equals 0, right? Now if I consider a linear equation in two variables, then I will be getting it as ax plus by plus c is equals to 0. This is a linear equation in two variables. What are the two variables here? X and y are two variables. Okay, so this is also a linear equation. Linear equation in two variables. Okay, now let us see what do you mean by pair of linear equations. Okay, so if I consider a linear equations two times, then we call it as a pair of linear equation, that is ax plus by plus c is equals to 0 is one equation, ax plus by plus c is equal 0 is another equation. These two together are called as pair of linear equations. So in order to differentiate them, I am naming the equations as a1, b1, c1 for the first equation, a2, b2, c2 for the second equation. So I will be getting a1x plus b1y plus c1 is equal 0 is the first linear equation in two variables, and a2x plus b2y plus c2 is equal 0 will become the linear equation in two variables. So now both together is called as pair of linear equations, pair of linear equations in two variables, okay. This is how we got two linear equations in two variables. Now let us see two types of solutions, that is, one is consistent solution and the second one is inconsistent solution. Okay, what do we mean by consistent and what do we mean by inconsistent? So if we consider any linear equation, if we have at least one solution, then it is called as in consistent solution or consistent equation. So in the consistent means it should have at least one solution for those linear equations. Okay, inconsistent is nothing but no solution. If a linear equation is not having any solution, then they are called as inconsistent solutions. Now let us see the graphical method of solving two linear equations. Okay, for that let us consider two equations as a1x plus b1y plus c1 is equals to 0 and another equation as a2x plus b2y plus c2 is equals to 0. Now these two are called as pair of linear equations in two variables, right? Here for these two linear equations we will be getting solutions, right? We will get one solution as x and y, right? So this solution will give us certain conditions, that is, based on the solution of these two linear equations we will get a first one as intersecting lines, and the second one is parallel lines, and the third one is coincident lines. Okay, so when we have the solution of this pair of linear equation, we have three things. One is intersecting lines and parallel lines and coincident lines. So out of these three, we will get any one of the type of the solution for the given pair of linear equations. Okay, so if we consider this as one straight line, right, and this is another straight line, as both are intersecting at one point, hence they are called as intersecting lines, and these intersecting lines will have one solution. Okay, as it is having one solution, we can call them as consistent lines. Okay, and the second type is parallel lines. So parallel lines will not intersect at any point, right? There won't be any intersection of the lines, hence they are called as parallel lines. As they are parallel lines, they will not have any solution, so they are called as no solution, and their lines are called as inconsistent lines. Okay, and then the third type is coincident lines. So coincident lines are nothing but both the lines will lie on the same line, right? This is first line on which we are having the second line. Both are intersecting as on the same line, right? Hence, as they are lying on the same line, they will have infinite number of solutions. Infinite number of solutions, and as they are having at least one solution, they are called as consistent solutions or consistent lines. Okay, so now from this what we can conclude is, in the graphical method we have considered two pair of linear equations. They are a1x plus b1y plus c1 is equals to 0, a2x plus b2y plus c2 is equals to 0. So for this pair of linear equations, we will have one solution, that is x and y. Okay, so from this x and y, we will be getting three types of things. One is intersecting lines, parallel lines and coincident lines. If both the lines intersect at one point, then they are called as intersecting lines. As they are intersecting at one point, hence they will have one solution. As they are having one solution, they come under the category of consistent lines. Okay, the second one is parallel lines. Parallel lines will not meet at any point, hence they will not have any solution. As they are not having any solution, they will come under inconsistent lines. And the third type, that is coincident lines, both the lines will lie on the same line, hence they are lying on the same line. They will have infinite number of solutions. As they are having infinite number of solutions, then they are called as consistent lines. Okay, we are going to start exercise 3.1 problems. That is, the first one is, Aftab tells his daughter, 7 years ago I was 7 times as old as you were then. Also 3 years from now I shall be 3 times as old as you will be. Okay, these are the two statements given by Aftab to his daughter. So now we have to represent this situation algebraically as well as graphically. So for that, first let us consider that our first step is to find two variables. So here the two variables are x and y. Those are, let Aftab's age be x, let Aftab's age be x, okay, and daughter's age be, y years. Okay, that is what first we have to assume two variables. We have assumed x and y as two variables. Now the first condition, 7 years ago. 7 years ago means Aftab will be also 7 years older, as well as daughter also will be 7 years old. That means 7 years ago Aftab's age will be what? X is his present age, right? Minus 7. Okay, and his daughter's age will be y is present age minus 7. Okay, so now what he has given, 7 years ago I was 7 times as old as you were then. That means 7 years ago the age of Aftab is x minus 7. His daughter's age will be 7 times as old as you were then, that is y minus 7. Okay, this is the first equation. From this what you can write, x minus 7 is equals to 7y minus 49. Get all the terms to one side. X minus 7 is equals to, when you are bringing plus 7 is here, it will become minus 7y. When you are bringing minus 49 this side, it will become plus 49 is equals to 0. So from this we can write it as x minus 7y plus 42 is equals to 0. This is the first required equation. Okay, now second one. What is the second condition? 3 years from now. Okay, age of both, that is 3 years from now. That is Aftab's age will be what? X is his present age, from now means plus 3, and daughter's age will be y is her present age plus 3. Okay, what is the condition given to us? I shall be 3 times as old as you will be. 3 years from now I shall be 3 times, that means x plus 3 is equals to 3 times of y plus 3. Okay, so from this x plus 3 is equals to 3y plus 9. Get all the terms to one side. X plus 3 minus 3y minus 9 is equals 0. So this will become x minus 3y minus 6 is equals to 0. So this is second equation. This is the second equation. Now we have represented them algebraically. Now let us try to find out these solutions graphically. So now we have two linear equations. They are x minus 7y plus 42 is equal 0. This is equation number 1. And x minus 3y minus 6 is equal 0. This is equation number 2. So now if I get the solutions for this, what I need to do? X plus 42 is equals to 7y. I am shifting this y term to that side. From this what will be y? Y is equals to x plus 42 by 7. X plus 42 by 7. This is the required y value, right? Now let us consider x values as well as y values. If I consider x as 0, okay, if I consider x value as 0 and if I substitute, what do I get? A y value. If I take x as 0, 0 plus 42 by 7, that is 42 by 7, 7 1 is 7, 6 is 42. So 0 comma 6 we got. Now if I take x value as, x value as 7 now. Okay, if I take x value as 7 now, what do I get? 7 plus 42 by 7, that is 49 by 7, 7 7s are 49. So therefore the values from this are x is 0 comma 6 and the other one is 7 comma 7. What are the values we got? X comma y is 0 comma 6 and 7 comma 7. These are the solutions of the first linear equation. Okay, I hope you got this. Understood? So we are just finding the solutions for this linear equation, first linear equation. Let us consider the second linear equation, that is x minus 3y minus 6 is equal 0. From that x will be equals to, I am shifting these two terms to the right hand side, then it will become 3y plus 6. Okay, so now let it be like that. We will consider certain values for x. Okay, x, y. So if I take x value as 0, what do I get? If I substitute x as 0, 0 is equals to 3y plus 6. 6 if you shift this side, minus 6 is equals 3y. Y is equals to minus 6 by 3, 3 1s are 3 2s are. Y is equals to minus 2. Okay, now if I take y value as 0, if I take y value 0, directly I'll get as what? 3 into 0 plus 6 is equals to x. X is equals to 6. Okay, so now I got the solutions as 0 comma minus 2 here and 6 comma 0, right? So now I need to go for the graphical representation of this two algebraic expressions. That is, if I take these values on the number line in the graphical plane, right? Now I consider the x and y axis here, right? X, y, negative x axis and negative y axis. So I am taking the values as 0, 2, 4, 6, 8, 10, 12, 14 and so on. Minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14. And next here 2, 4, 6, 8, 10, 12, 14. Okay, here minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14, minus 16. So now the first value is what? 0 comma 6. On the x-axis 0 and y-axis is 6. So this is the first point. And the second point is 7 comma 7. X-axis is 7. So it will be here. Y-axis also will be 7. It will be here. Okay. So when I plot the line, it will be like. Okay. So this is the line for the first equation. This is the straight line which will be for the first equation. Now for the second equation, 0 comma minus 2. Right. 0 comma, this is 0 and minus 2. And next one is 6 comma 0. 6 comma 0 means it will be on the same line. So if I extend this, okay, this both will intersect at the point P of 42 comma 12. Okay, when you extend it properly, it will be intersecting at P of 42 comma 12. So that is the age of the father as well as the daughter. So x is 42 years and y is 12 years. Now problem number 2, that is, the coach of a cricket team buys 3 bats and 6 balls for 3,900, and later she buys another bat and 3 more balls of the same kind for rupees 1,300. Okay, represent this situation algebraically as well as graphically. So here first step is to what? Decide what are our two variables. So here we have two variables as bats and balls. So let x be bats and y be balls. Okay, so from that what you can frame, we have first situation mein 3 bats, so 3x plus 6 balls 6y is equals to what is the amount? 3,900. So this is the first equation. Okay, in the second case we have 1 bat, that is x, plus 3 balls, so 3y is equals to 1,300, is equals to 1,300. So now we got two linear equations in two variables. Now let us solve them and find the solution for this. Okay, so for that I can take 3 common in the 2 common in the first one. Now let us take 3 common, that is 3 ones, 3 twos, 3 ones, 3 threes, 0, 0. So therefore the first equation will become x plus 2y is equals to 1,300. From this x will be equals to 1,300 minus 2y. Okay, so now if I take table for this, x, y, if I take y as 0 first, if I take y as 0, then x will become 1,300 because this whole part will become 0, right? Now if I take x as 0, then what do I get? If I take x as 0, 0 is equals to 1,300 minus 2y. From that 2y is equals to 1,300, 2 ones, 2 6 12, 650. So y will be 650. Okay, so now this is the solution of the first equation. Now let us find the solution of the second equation. What is the second equation? X plus 3y is equals to 1300. So from that, x will be equals to 1300 minus 3y. Now again consider x and y values. Okay, x and y. You can take any values of x and y, but I am taking for simplification. Once I am taking x0, the other time I am taking y0. This is for simple calculation. Okay, if I take x0, then I will be getting it as 0 is equals to 1300 minus 3y. From that, 3y is equals to 1300. From that, y is equals to 1300 by 3. So it will become 3 1s are 3, 3 4s 12, 3 3 is 9, 3 3 is 9.3. So 433.3 it will continue. Okay, and if I take y value as 0, I will be getting x as 1300. So these are the solutions of this two linear equations. Now let us go with the graphical method of representing. So as I don't have negative axis, I am considering only a positive side of this, right? That means this part 0, 100, 200, 300, 400, 500, 6, 7, 800, 900, 1000, okay, 1100, 1200, 1300. I have taken till 1300 because I have 1300. Next, on the y-axis, 100, 200, 300, 400, 500, 600, 700, 800, 900, okay, 1000, 1100, 1200, 1300. So from the first table, we have the values as x is 1300 and y is 0. So this is the first value. And in the second one, 0, 650. X-axis is 0 and y is 350. So I have to draw a line. I am trying to draw a straight line. You can use a scale for this. Okay, so this is the first line for me. Okay, this is the equation number 1. Next, x is 0 and y is 433 point something. So I am placing it 430 somewhere. And second one is 1300, 0. That means same point. So it will be like, so both are intersecting at one point, right? Both are intersecting at one point, that is 1300, 0. Okay, so this is the intersecting point of x and y, right? So therefore the cost of the bat is 1300 and ball is 0. Now the last problem of this exercise, that is the cost of 2 kgs of apples and 1 kg of grapes on a day was found to be 160. After a month, the cost of 4 kgs of apples and 2 kgs of grapes is 300. Represent this situation algebraically as well as graphically. So for that, first let us consider 2 variables. So let x be apples and y be grapes. Okay, so from the first situation, what you can write? 2 kgs of apple. So 2x plus 1 kg of grapes, 1y is equals to 160. This is the first equation. And second one, 4 kgs of apples and 2 kgs of grapes was to be 300 rupees. So this is algebraic way of representing pair of linear equations in 2 variables. Okay, so now let us try to find out them graphically. For that, we need to find their x and y values. So 2x plus y is equals to 160. Okay, from that, let us take this as x, y table. Okay, if I take x as 0, this whole term will become 0, y will become 1600, and if I take y as 0, x will become 800. Okay, and similarly the second equation, that is 2y, from that 4x plus 2y is equals to 300. Okay, so now take x and y. Take x as 0, then y will become 150. Take y as 0, right? 300 by 4 is how much? 4 ones 4, 4 sevens are 28, 2 will be there, 4 5s are 20. So x is 75. So now from that, draw it, that is by considering a graph. Okay. Let us take on x-axis we have 0, 800, 0, 75. I think we can take 50, 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800, 750 and 800. On the y-axis, let us take as 100 units, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1100, 1200, 1300, 1400, 1500 and 1600. The first one is 0, 1600. 0, 1600, the first one. Second one is x-axis is 800, y-axis is 0. So this is the first line. X-axis 800, y is 0. This is the first line. Okay, and the second one is 0, 150. 0 and 150 will be here. And second one is 75, 0. It will be 75, 0. So if you draw this, so both the lines will be parallel to each other. Okay, these are called as parallel lines, hence they will not have any solution.